Good evening, everybody. Thank you for joining us, and thank you to Sheehan for putting this on. We're going to talk to you today about our experience aggregating data from multiple microservices to link AppLearn resources together. We're going to talk about the motivation for that, the architecture and the design, and then the sort of the challenges and lessons that we learned along the way. So hi, I'm Simon. I'm a software engineer for the last 20 years or so. I've been an architect for the last 3. I started at AppLearn 6 years ago now as a senior engineer. I'm passionate about finding simple solutions to complex problems. I'm a keen cloud and serverless advocate, not server. And I just like making products, really. And so obviously in work, that's with software. In my free time, I have a woodworking workshop, and I like to make and design products and sell them on Etsy.
And I'm Thara. I'm lead engineer at AppLearn. I've been at AppLearn for about a year and a half now, where I've worked on some really cool projects, one of which we're going to talk about today. And I've been in software for over 15 years now, and I really enjoy making solutions to problems, but I especially enjoy seeing that being used and appreciated by a person at the other end. And in my spare time, I enjoy making cakes for friends and family, for special occasions, and just generally eating.
Don't we all? So who's AppLearn? At AppLearn, we make a digital adoption platform, or a DAP. That is, so our platform sits on top of vendor applications such as CRMs and ERPs, the likes of which you'd have come across like Workday or Salesforce, Oracle. And we provide tailored help to users to accomplish complex business workflows. We also provide analytics for administrators to be able to sort of dig in and see what their users are struggling with, and then sort of use our tools to address those problems. We've got customers across the globe in all sectors, Rolls-Royce, Coca-Cola, EY, companies like that. And to give you an idea of the sort of scale we're operating at, we have around 100,000 active users a day and about 1.6 billion requests a month. So I want to talk to you about the tools we're actually using then to help those users with those complex business processes. So we provide these contextual resources, as we call them, or sort of widgets basically, that sit within the vendor system, overlaying what the vendor system is providing. And so if you can see at the top left, you can see an example of a smart page, and that's basically a big modal that takes over the screen, forces you to interact with it, provides lots of useful information, and then you can see sort of some buttons along the bottom to progress onwards. And then at sort of the other end of the spectrum, at the bottom, you can see an example of a tooltip. You've probably come across these before. They float next to the relevant piece of information. They give you a little bit of help with that, and then you can interact with that via the buttons, much like the smart page. You can ignore it if it's not relevant to you, or you can just dismiss it. And a really powerful thing with our resources is that these things can actually interact with each other. So in this case, this smart page, this guided tour button actually triggers the tooltip to display on the page in the first place. So the smart page would appear, and you'd select the appropriate button, you'd click on the guided tour, the smart page would then disappear, and that tooltip would appear against the relevant element. And we can use this to create really quite complex sequences. So in this case, a sort of a 9-step process. I've only put 3 on the screen. You can click the next button to trigger step 2, step 3, step 4, etc. We can put a previous button on so that you can come back up. And that can then really follow through and give you really good help exactly where you need it. And so if we just have a look at this demo, you can then see these in action. Thank you. So typical smart page appears, gives you a little bit of information. There might be a video or just some text, and then you've got these 4 buttons. And in this case, we're going to click on the guided tour. That's going to trigger this tooltip next to the bot. Just gives you a little introduction to it. You can click the feedback, but in this case, we'll just dismiss it. So if we click through into the create job requisition, the form on this page is really a really great example of the sort of places that we're providing help. It might seem like a full-time employee is really obvious, but actually you're not quite sure are they 39 hours. In this case, a full-time employee means somebody that's working 40 hours. And you click on next, and it takes you through to the next tooltip in the sequence. So we've established that tooltips can trigger tooltips and that smart pages can trigger tooltips. But in all honesty, it's a little bit of a hack. The tooltips and smart pages, they're widgets in their own right, and so they have microservices behind them supporting them. And for smart pages to be able to trigger a tooltip, it actually needs to know that the tooltip microservice exists. That creates a dependency that we really don't want. That means it can't scale. But in any case, products come to us with a new requirement, pretty predictable. They'd like tooltips to be able to trigger smart pages and smart pages to be able to trigger smart pages. And we're having to think. It's not a massive leap of imagination, but it occurs to us that at some point product might come along and ask us to add a new feature, a new widget. And if they're going to ask us to add a new widget, you can be pretty sure that they're then going to ask for that widget to be able to trigger tooltips and smart pages and vice versa and trigger itself. And so really what we're actually talking about is AppLearn things, AppLearn resources can trigger themselves. But what about things outside of AppLearn? Maybe a service such as ServiceNow, a common repository that businesses use. Things like they have things like PDFs and rich text, and if we can have them trigger AppLearn resources and AppLearn resources trigger them and they can trigger themselves, that sounds pretty good. Or SharePoint, much more common. Everybody should be aware of SharePoint. They have a massive range of the things that we can put on the page: videos, Word documents, Excel spreadsheets, PowerPoint presentations. And of course, at this point, you've figured out we're actually talking about anything can trigger anything. So if there's a resource that you can put into a web page, we can link it to another resource. Anything can trigger anything. So what's the problem? If you imagine this is an admin system, you've selected the tooltip that you want to administer, you've chosen the name of the button that you want to put at the bottom. It might be more info or something. And then you want to decide what resource that's going to trigger. Maybe it's something from SharePoint or another tooltip or who knows what. And you're going to expect to see that list of resources that you're going to pick from. And the problem with that is that microservices aren't terribly conducive to that. Our admin would need to query each of those microservices and then amalgamate all of that data into one big list. And there could be 5 or 10s or hundreds or thousands. Let's try and keep it below thousands. So the solution there is to create some sort of aggregation. And so that's what we decided we need to do. And so we come up with a list of requirements. And our requirements are pretty straightforward. We want to aggregate resources from across all of our microservices. We want to be able to present them in one list to the administrator. And of course, if you've got a list, at some point it's going to be a big list, and then you need pagination and sorting and searching. So once we come up with those requirements, we had a little sit down, put our heads together, and Tara's going to tell you the solution that we came up with.
Thank you, Simon. So as Simon mentioned, we've got different microservices and we need to aggregate that data. But before I show you how we did it, I just want to explain how we save our saving process for each of these microservices. So on the left, you'll see a screenshot of our admin tool that saves tooltips. We've got a similar one for smart pages. And when you click save, a request is sent off to its respective microservices, one for tooltips and smart pages. And as you can see, they don't know anything about each other. They're completely isolated. And so what's happening here is the request goes through, it hits our API gateway, which is integrated to our Lambda, which takes the request data, creates the save request to our DynamoDB. So, how did we aggregate this data? So this is a high-level diagram of how we did it. I'll quickly take you through it, but in the next few slides, I'll go into more detail about each of those processes. So what we did was we created an uncoupled system that would take data from each of our microservices and aggregate them to a common data store, which in our case is Elasticsearch. We use DynamoDB streams to emit events about any of the DynamoDB operations, and we used the Lambda to take that stream data and create an event bridge event. Event bridge would then receive that event and use filtering using event buses to then target the application, which in our case is the Lambda, and that would save the request to Elasticsearch. So starting back at the top of that process, we start with DynamoDB streams. So DynamoDB streams is a service AWS provides that emits events on any operations in DynamoDB. And it's a good catch-all for us because it doesn't matter how the data's saved. It could be saved through our admin tool or even manually on the AWS console. We'll catch it all. So it's quite robust in that way. And it's got really good integration with Lambda. And we love using Lambdas at AppLearn. It gives us loads of benefits out of the bags. It auto-scales, it has auto-retries on failures, it's cheap, you only pay for the invocations, and it's got good integration with dead letter queues, which I'll talk about later. So in our case, this Lambda's doing three things. It receives the stream, it filters out the events it's interested in, which in our case is insert, updates, deletes, and then it adapts that data to a format that Event Bridge is expecting. And then it creates a put request to the event bridge. So the second part of the process is the event bridge. Event bridge is a service provided by AWS that basically connects source applications and target applications via events. And it uses event buses and rules to basically filter out the events it's interested in. And once it passes those rules, it will then invoke its target application. So in our case on the left, you'll see the rule that we created in our event bus. It's saying that when we get a payload, we're only interested in events with payload which has an operation type, insert, update, or delete, and we're only interested in events that are coming from these sources in that array there. So we receive that event, and it applies pattern matching, and then if it passes those rules, it will invoke the target Lambda. So the final part of the process is the Elasticsearch. We have the Lambda that receives, the bit on the left is an example of the event that we will receive. The Lambda will receive that event. It still has the same benefits that I explained earlier, auto-scaling, auto-retries, etc. And it will take the data that's within the detail section of that payload and create a put request, HTTP put request, to save that into Elasticsearch. We chose Elasticsearch because of the requirements Simon mentioned earlier, which we need like pagination, sorting, filtering, searchability. And Elasticsearch provides that really well. So now that I've explained those processes in a bit more detail, hopefully we can take a step back and see how we created this system to aggregate this data into Elasticsearch. But nothing goes according to plan, and you should always handle the unexpected. So in our case, in each of these sub-processes, we used SQS dead letter queues. So whenever an error happens in each of these processes, it will send a message to SQS. SQS then triggers a CloudWatch alarm. CloudWatch alarm has an action to then send a notification to the SNS topic, and the SNS topic is configured then to send an email out to our email incident monitoring group. So that's how we get notified of any fail-saves. And it's dead easy to sort it out because the email will contain the information about the offending resource that failed to save. All we have to do is then go back into our admin tool and resave that resource, and job done. Sorted. So we have our lovely system where we can get aggregated data from different microservices, but we need to populate this now. So for us, we used step functions. And step functions is a service AWS provide that allows you to create quick workflows that are really easily integrated into AWS services. So we created a step functions for each of our microservices. So one for tooltips, one for smart pages. And we had basically 3 steps. One to read from DynamoDB, one to invoke a Lambda to adapt that data, and one to create a put request to EventBridge. And the rest is taken care of because EventBridge will receive that event, Event Bus will apply filtering, and if it passes rules, we'll invoke your target Lambda. So we've got our system that aggregates data into Elasticsearch. We've got a mechanism to handle the unexpected, and we've populated our data across with all our microservices. But we had challenges along the way. The first one is Terraform. We use Terraform as our IAC for all our infrastructure, or most of it. So naturally, we wanted to use Terraform to create our Elasticsearch cluster, server, nodes, index, aliases. And AWS did provide was a provider for the Terraform for the server side of things, like the cluster and the nodes, but there wasn't a very good provider for creating the indexes and aliases, so we had to create our own code to do that. The second part was step functions. We found out that there's quota on the number of events that step functions can handle. So every time you run a step, it's emitting an event. So every time we're reading from DynamoDB or invoking that Lambda, an event is being generated. And because we've got a lot of data in our DynamoDB, we quickly filled up this quota. So we had to break our step functions down into smaller step functions that would run for per customer instead of across everything to get us below that quota. The third one was Elasticsearch. We're used to serverless, but Elasticsearch isn't, and it doesn't auto-scale. So we had to spend a long time up front thinking about our use case, how it's going to grow, what do we need from it. We had to think about cluster sizes, nodes, number of shards, availability zones, failover. It was a lot. So it's a lot of time that we had to think up front. DynamoDB streams, there wasn't a lot of clear documentation at the time on how it would handle failures. And after a bit of digging, we found actually if there's a failure in a stream, it would actually keep retrying indefinitely, and it would keep queuing up the pending requests behind it. So we had to put policies in place that would basically fail that request after a certain number of retries or duration, whichever one came first. And finally, EventBridge, there was a little bit of contradicting documentation on the schema it expected for that JSON. Some would have it in camel case, and others would have it in kebab, so a bit confusing there. But we overcame all the challenges, and it worked. We created a product that would allow us to select a resource to trigger any other type of resource. In our case, the first use case was a tooltip to trigger a smart page. But really what this really meant was significant because it threw the doors open. So now instead we can actually get anything to trigger anything. So in this video I'll show it's basically that first use case of the tooltips being able to trigger the smart page, but keep in mind how significant it was. So we have here our admin tool, and what you're going to see here is a tooltip being configured, and it's going to set up a button that's going to trigger a smart page. And this list is significant because this is actually being pulled back from our Elasticsearch, showing all our aggregated data. So it's selected a smart page as its target, and it's going to save that configuration. And then we're going to go back into our system and see a tooltip eventually show up. So when you click the button, it's now going to show, like, triggering a smart page. Voila.